with that, we get started. All right, it's my great pleasure to welcome you all to our demo day today of the third edition of the Quantum Entrepreneurship Laboratory. We're thrilled to have you all on the call, whether you're here in the Zoom, and I guess there's also a couple of people that join via the YouTube live stream. For my part, I'm extremely excited to see what our teams have come up with today. And as I would say with that, we jump right in to check what's on the menu for probably the next roughly 2 hours today. So we'll start with a short introduction about the course itself. What is the Quantum Entrepreneurship Laboratory about? How is it set up? That also will give me the chance to briefly introduce the two organizations that organize this program, but also to thank a couple of people that are crucial to actually make it happen. And it's always a nice opportunity to do that. We'll afterwards have a quick introduction of our wonderful jury that we have with us today. So I'm looking forward to that. And after that, we'll come to the main part of this session today, which is the pitches by our teams. And that gives them the chance to showcase what they've been working on over the last couple of weeks. We'll always have a roughly 10-minute investor-style pitch by each of the teams, and then a Q&A session for about 10 minutes as well with our jury, so that they can ask the interesting questions and challenge them a little bit. After that, we have actually a quick outro, and then we'll end the YouTube stream, but we'll have a couple of breakout rooms here in the Zoom call so that you can interact with the teams directly if you have further questions or you would discuss individual points. With that, I would say I'll jump right into the program setup. The journey of our Quantum Entrepreneurship Lab this winter semester started back in October last year. We once again had little more than 100 applications for the program, which is always tough because typically the quality of people that apply is already pretty high, and because we only have 20 slots, we need to pick the best ones. And I think we, again, could pick 20 really outstanding participants for the program, and we're really happy about that. These 20 people start, and we at some point mix them together into teams. And at least from my perspective, I'd say this is one of the things I like the most about the program, because we have 3 different roles. We bring in always people that we call our quantum natives, typically from the physics or electrical engineering departments. We mix them together with our business developers coming from the business or management side. And we also have somebody from, always one person from the computer science department. And seeing these people interact and seeing how much they already can learn from each other in a couple of months is always super encouraging, and something I really appreciate a lot about the course, and also this semester again showed really great benefits, I would say. And these teams, there's also another crucial part, so that they can actually work on something that is applicable and that's a real world problem. These teams get matched with our challenge partners, and we are really blessed to have again a wonderful group of challenge partners on the program. This semester we had E.ON, Merck, Main Incubator, which is basically the think tank of Commerzbank, and BMW on the program. So thanks to all these guys to make sure that the problems that the people or students are working on are really relevant, and there's a worth to be solved. From a temporal perspective, the program starts with a kickoff boot camp. So once our students get accepted, there's 1 week where we honestly throw a lot of input at them with typically 4 lectures in 1 week. And we also add a couple of networking sessions so they can connect with each other, learn what everybody's kind of willing to work on. That's also the week where they can select which team member they want to work with and which challenge partner they do want to work with. Once that happens, we set them up into the teams of 5 typically. And that's the beginning of the ideation phase, where they start to reach out to their challenge partners. They get introduced to the problem space, and they start to pick specific problems where they see a potential solution and the problem they want to work on. Once that is done, we are typically at the end of the ideation phase. The teams have 1 to 3 problems they think are worth solving. And from this set of problems, they pick one for the next phase, which is the prototyping phase, where they really go in depth on that single problem and design a solution to the problem based on quantum computing, of course. Within the prototyping phase, there's a short midterm presentation where they can collect feedback from our team, from the challenge partners, to kind of advance the solution further. And now we are in the last phase of the program, which is the delivery phase, where the first element is today's demo day, basically the final pitch where they showcase their solution. And the last element of the program is then always a final written report, where it's also a bit more technical, because obviously today in the investor style pitch, there's a limited technical depth involved. With that, I already said there's 2 organizations actually that run this course or run this program. And I want to briefly take the time to introduce those 2 organizations. And for the first one, Push Quantum, I would like to briefly hand over to Yannis, who is the president of Push Quantum.
Thanks, Christopher. Yeah, just a few words about us. So I'm Yannis, as Christopher said, president of Push Quantum. We are a students club. Our mission is to enable our members to have successful quantum careers. For this, we have offerings like the Quantum Entrepreneurship Laboratory that we are offering together with the 2 venture labs now for the 3rd time. Also, to name a few other offers that we have. We had the Leadership in Quantum series last year, where we were interviewing some key players in the quantum field that you could see. You could follow this on YouTube, basically, see the interviews, and also had the opportunity to ask some questions afterwards. We also started company visits now. We have been to AWS last week and to BMW this week. There are more to come, and I think this is a very successful format. And also, just to name this, we also have a climate task force initiated and run by 2 of our members, Valentina and Emily, who will also present today. So it's just all about quantum. And if you have any ideas that you would like to see in Munich or together with us, then feel free to reach out to me or to Franz. You can reach us either on the Slack or on LinkedIn, and we'd be very happy to see more engagement in our community and more offers that we can have. And with this, I'm very excited to see your presentations today. I think you have done a very, very good job over the past months. I myself have been in this situation 1 year ago. I participated in the 1st edition of the Quantum Entrepreneurship Laboratory. That's actually how I joined Push Quantum, and I'm very happy to be here. And yeah, thanks.
Thank you, Yannis. And I would add that Push Quantum was actually the organization that kicked this program out of the ground in the first place. So special thanks there also to Tom and Raul, who did it back in the days. I think amazing effort, and we still keep it running, and I'm still a big fan of the program. So briefly, maybe to the second organization that is now part of the organizing the whole thing, which is the TUM Venture Lab Quantum. So the TUM Venture Labs are actually a new initiative of Unternehmertum here, our entrepreneurship center in Munich, and the Technical University of Munich. We are really building on top of these 2 pillars with a really large entrepreneurship center and an entrepreneurial university. We added the setup of really domain-focused venture labs, which means we really focus in specific areas, which I run on the quantum side, to help people with ideas, to bring them to life and actually build successful startup teams. The main effort we have typically is on the side when people actually come with ideas and we really develop startups out of them. That's where we take them by the hand and guide them through the process with actually also bespoke infrastructure and ecosystems for all of the labs. But one actually really important element is also on the educational side to actually, on the one hand side, bring in the entrepreneurial spark to the physicists and the quantum experts, but also, as you see in this program, actually bring quantum computing into the computer science department and the business to the business students. So I think that's a wonderful example of how our educational programs should look like. And of course, we're always happy to be in contact with all of you. Also, if and obviously hope that some of you will actually develop some startup out of the efforts you have already started here in the program. With that, very briefly on a couple of very important people that helped us also getting this course running. And first up, our academic coordinators, who make sure that actually this program is not only a standalone program, but integrated into the study program of TUM. So our students can actually get credits also for their studies. I think that's wonderful, and they always put in a lot of effort and also put in their knowledge and teach our students on the academic parts of this program. So special thanks also to Stefan, Christian, and Frank, also all part of the jury today. So you have the chance to roast the teams with your questions later. I'm looking forward to that. The other very crucial element I said it before already, are our challenge partners, because they really ensure that the problems the teams work on are actual problems that are present in industry and in the real world. I said it before, we have Corey from Eon, we have Thomas from Merck, Augustine from the Main Incubator, and Elvira from BMW. But I also want to mention that I know you always involve a lot more people from your organization that help the teams and work with the teams. So big thank you on that side. The other part we always bring in from the outside, something that I've always found very impressive about the program, is the speaker series that runs along the program. So we have a weekly lecture or weekly talk by actually a wonderful lineup of speakers. I don't want to go through the list here, but big thank you to all of you here. It's really crucial input for the teams to build their solutions and to understand the space they're operating in. So this is really, really valuable. And also these people are typically, our speakers are really, really busy people, and make them taking 1.5 or 2 hours on Monday evening to share their knowledge with the students and answer all the questions, I think is a wonderful, it's just a great thing for us. Then for me personally, there's one team I want to give my special personal thanks to. These are our teaching assistants. They take a lot of the organizational load. They make sure the program actually runs. And also, I think in the name of the teams, a thank you to this group, because they help the teams throughout the semester with the little questions, with input on which direction they should take at certain points. So guys, really big thank you also to all of you. You really make this work. And I'm super happy that you were all on board this semester. Cool. Actually, also don't want to speak so much more. This is today really about the teams and what they have done. So the next point is our jury, but I also don't want to introduce all of you. I would say we go just along the pictures, and you briefly introduce yourselves, who you are, what you do, and after that we can finally get to the main part of the program today. So Stefan, if you want to make the start, feel free.
Yes, sure. Thanks, Christopher, and thanks for also to everybody who have made this happen. And I'm really looking forward to the talks. A little bit about my person. I'm a professor at the TUM since 2020, and I'm working on experimental implementations of quantum computing with superconducting qubits. I'm doing this quite for a while. It's also now, I think, my third time that I'm here at the jury, and I'm always looking forward for the new ideas that are showing up here. And so thanks, and I'm enjoying it. And
thank you. Frank?
Yeah, my name is Frank Kollmann. I'm a condensed matter theorist here at TUM. And I'm interested in understanding sort of novel quantum phases of matter. And in this context, a couple of years ago, I also got quite interested in the potential of quantum computers. And now we are exploring ideas about developing quantum algorithms. So yeah, very much looking forward to this presentation, and also thanks for everyone involved to make this work. Thanks.
Thank you, Christian.
Yeah, thank you, Christopher, and everyone for organizing this, first of all, and making this work and run so well. I'm Christian Mendel. I'm a physicist by training, and right now I'm in the informatics department. So actually, we're working really on quantum computing from the side of algorithms. And also on so for example, how you could to simulate the target system, and also a lot on numerical methods for classically simulating quantum systems. So I think it's a very interesting and of course very broad field also, and it's always, I mean, what I really want to highlight here is it's always a lot of enjoy really a lot to work with talented and motivated students, right? It's always really nice. Okay, yeah, looking forward to the talks.
Thank you, Christian. And from the academic part of our jury to the industry experts, Jan.
Yes, hello everyone. I'm dialing in from Finland today. But as many of you know, I have a very strong connection to Munich. I got my scientific education there at the WMI. And then I was at some point lucky enough to have the chance to make the transition from science into entrepreneurship. And now I'm leading IQM since summer 2019. So I'm really looking forward now to the talks soon.
Thank you, Jan. So next would be William Hurley.
Hi, I'm William Hurley. I'm the CEO of StrangeWorks. I'm very interested in this. We're actually opening an office in Munich, so we're very tied to that scene. I grew up in Nuremberg. The best thing I've done in physics is write a baby's book with Chris Ferry, so don't look to me for any of the physics questions that these other guys are doing. But I advise several investment firms on their investments in quantum, as well as StrangeWorks will soon announce that we'll be making investments in quantum startups. So I'm super excited to see what you guys have put together today.
Yeah, thank you, Early. And I think a special thanks because it's, as I understand, it's pretty early for you in the day. So thanks for dialing in. Cool.
It's actually not too early, but
okay. All right. With that, to the investors we have in the jury, Emily.
Yeah, hi everyone. I'm a deep tech investor at an early stage venture capital firm called Speed Invest. Physicist by training, like most people in the room, but switched to the dark side, to the investor side of the table, and try my very best to maintain scientific credibility in investing in deep tech startups. Quantum has been my main investment focus, and this is the second jury that I take part in as part of this project. I have to say I was really, really impressed the last time around, so I'm super keen to see what everyone's put together. So thank you.
Cool, thanks for being here. Jean Gabriel, do we have you? Probably not, then let's jump on to our challenge partners. Corey.
Yeah, hi everyone. My name is Corey O'Mara. So I also am from Munich. I did my PhD here at TUM some years ago. And currently, I'm quantum computing lead at Eon Digital Technology, where I oversee the technical implementation of our quantum solutions. So really looking forward to today. I love taking part in the QEL, and as always, it's a pleasure.
Thank you. Thomas.
Yeah, Thomas Immer from Merck, and it's really a pleasure to see so many familiar faces. It feels like home. So I'm one of the co-founders of Merck, our quantum computing task force 3 years ago. I'm physicist by training, and I'm donating my time and my face, and sometimes get hit by our colleagues why I do that. Really to sponsor challenges here to students, and I'm really super excited how this develops, and I'm also happy to see that, for example, Clarissa and Shruti are here making next steps, and yeah, it's interesting to see, to provide real cases and also help the students to learn, getting from idea to now, oh shit, we're on the investor side. So Emily, trying to join you with a nasty role. But it's super helpful to see the struggles. It's also helpful for us, and I'm really excited to be here, and then definitely go in for the next time again. So if we can.
Well, we'll be in touch for sure. All right, Jens.
So hi everyone, my name is Jens Jeschner. I'm a data scientist at Main Incubator, and I'm working on quantum and machine learning topics there. So I'm primarily focused on finance, especially quantitative finance, and yeah. I'm really looking forward to this and see what the groups come up with. Yeah, thanks.
Cool, thank you, Jens. Elvira. last but not least, of course.
Thank you. Yes, thank you very much for invitation, first of all, and for such great organization. So I'm Elvira Shishinin. I work in BMW Group Development Department and also leading research and exploration of quantum computing applications in there. By formation, mathematician, so had a conversion, I guess, as many of you here, but very happy to be here, and also wanted to introduce my colleague Marvin Erdma, who is a research scientist in BMW and who actually worked together with a team who helping them to leverage this challenge of supply chain optimization that we will work on today. So yeah, thank you very much one more time. Great initiative. Very happy to participate and call us next year as well.
Okay, thank you very much. We will. All right, so we're very close to the heart of the event today. Last thing I want to mention to everybody on the jury, you have the Google Forms to give feedback to the teams. So kind of it's time to pull them up because we jump right in to the first presentation for the day. I'll stop screen sharing. First up would be Team Multum that worked with BMW for the last weeks and months. So guys, feel free to share the screen and take it away.
Okay. Can you see the screen?
Yes.
Nice.
Perfect. Hi, everyone. For the last few months, our team has been working together with BMW on some really powerful ideas, and we're very excited to share them with you today. So let's dive in. I want you to imagine that you are a car manufacturer. And as a car manufacturer, you produce several different car models, which can each have customizable colors, interiors, and other features. Each car model consists of thousands of different parts, which must be assembled and painted before they are delivered. And because you have become quite successful in recent years, the complexity of your supply chain is increasing. Not only do you need to make sure that you have all of the parts you need at each plant when you need them to keep up with demand, but you would like to optimize the transportation of these parts with regard to cost. And because you are a mindful business person, you care for your environment and also want to make sure that you are taking steps towards a greener future by reducing carbon emissions. And you've looked around and have noticed that you are not the only one faced with these problems. Manufacturing companies struggle to accurately forecast their demand and to optimize their supply chains with respect to cost and emitted CO2 as their supply chains grow in complexity. Below are some statistics that we've collected from our partner, BMW, that illustrate the massive scale of these supply chains. Many manufacturers turn to classical solutions in an attempt to address these issues. But classical software simply cannot efficiently tackle mathematical problems of this scale. To address these increasingly significant issues, we have created Multum, an ERP extension that harnesses the power of quantum technology to forecast demand and optimize complex supply chains.
Multum uses quantum technology to accurately and efficiently predict demand over specified time periods. Secondly, the software optimizes the manufacturing supply chain with respect to cost, while also, and thirdly, taking into the account the environmental impact of the various phases of the supply chain and minimizing over the parameters related to them. At Multum, we implement a two-tier approach to make this happen. In the first step, our software takes sales data from previous time periods as an input, which is used to train a machine learning model called random forest. Then it outputs a forecast for the demand of different car models in future periods. While random forest approach is a classical one, the sheer size and complexity of BMW's supply chain requires the algorithm to be scaled using quantum technology. The next step in our approach uses this forecasted demand, translate this to a part list, and uses a hybrid approach of quantum annealing and classical computing by implementing D-Wave's discrete quadratic model solver to solve the single period multi-echelon optimization problem that describes the supply chain and takes into account this demand and a variety of constraints related to cost, CO2 emissions, and physical limitations. This two-tier approach allows the Multum software to deliver an accurate and optimized supply chain model with an efficiency only attainable with quantum computing.
By using D-Wave hybrid solver for the discrete quadratic models, the process of solving the optimization problem experiences a phenomenon called hybrid acceleration, resulting from the quantum queries which effectively narrow down the solution space for the classical algorithm, thereby dramatically reducing running time. In fact, we see a faster convergence towards higher quality solutions, meaning this approach is both more efficient and more accurate. If we consider the random forest algorithm, we can see a clear advantage for the quantum approach for large problem sizes, as can be seen in the plot here. And as an outlook for the future, with the addition of a 5,000 qubit system and the launch of the DQM solver, hybrid solvers could operate with up to 1 million variables. Our product itself is an extension to the ERP software of your company. The user in the front end has the possibility to adjust some simple parameters, like car models or forecasted period. In parallel, our algorithm will extract the required information from the company's database, and by using quantum technology, it will generate a policy which indicates how many parts are needed when and where. Now let's have a look at the following demo in order to get a clear view of our idea.
So let's first have a look at the forecasting part of our ERP extension. The user first selects a database and then dictates a time horizon as a basis for the forecast. For this example, this period is 1 year. Additionally, the user selects the product for which the demand will be forecasted. In our example, these are BMW car models. We select more than one models as many parts are used in more than one car. Then the forecast is generated and visualized. In the next part, based on the imported forecast, our algorithm checks for shortages in the inventory. For the parts with status not requested, an order will be created and forwarded to its supplier automatically. Lastly, the user visualizes the schedule for the incoming parts from the suppliers, either on a map or in a bar chart. By following the simple steps shown in our demo, our customer has timely requested all needed parts to satisfy demand. A smooth logistics flow is achieved by avoiding production shortages. Now, regarding our market, it is born by the intersection of the quantum computing market and the ERP software market. As you can see, both of these markets are considerably big already. And although we do not target the whole market of each category, as these markets grow, the shared area between them is also projected to grow. Noticeably, both markets are characterized by an upwarding trend. In terms of segmentation, we aim for customers active in the discrete manufacturing sector with big supply chain complexity, where cost savings scale because of big production volumes. And with that, let's take a better look at our customer profiling segment.
Our customers are automotive companies that aim to achieve operational excellence and sustainability by optimizing costs in the supply chain. We are going to engage with managers and directors who seek to increase their revenue and the performance of their departments, meeting the cost objectives and adhering to environmental policy settings. To retain customers and prospect new ones, we will implement an omni-channel communication approach by using different channels. Why? Because we believe so we can provide a customer experience that is seamless, regardless of the channel our customer use. Our product will be licensed on a subscription basis and paid on a monthly or multi-year contract basis, because we want to offer our customer the advantage of lower upfront cost to license the software. We are only in the beginning of our entrepreneurial life, and this is our goal for the near future. First, we will increase our algorithm robustness and ensure that our MVP can bring valid results. After we have achieved this, we are ready to reach out to our first customer and offer a solution tailor-made for their needs. That will be followed by a phase of a continuous improvement and broaden the applicability of our product. This will help us approach even more customers, and we are ready to enter a growth rapid phase by 2025.
Our amazing team consists of members from a variety of different academic and cultural backgrounds, which has allowed us to blend our various approaches and harness our collective strengths to come up with a game-changing product. So, when your company asks how many orders, how many products, how much complexity can we introduce into our supply chain model? How much can we reduce our costs and our CO2 emissions? Our answer is very simple. Multum. A lot. Thank you very much.
Thank you, guys. Big virtual round of applause for you for making this amazing start. Really, congratulations. And with that, we can jump into the Q&A part of this. If you are part of the jury and you have a question, would be great if you could use the raise your hand feature. So I know you have a question, and then we can go in that order. Frank, you were the fastest, so you can go first.
Right, so you showed the schematic plot showing basically how the quantum algorithm is more efficient. But that, as I understood, was just a schematic plot, or is it based on simulations that you performed?
This is just a schematic, so we know how the algorithm scale. So for us, only the scaling was interesting. So the offset between the two graphs are arbitrary. We only know that we know that the quantum algorithm at some point, from a mathematical point of view, will be faster than the classical one.
But I assume that there would be certain assumptions on the coherence times, on the qubits, etc. So given the current hardware, would we already be able to outpace classical computers? Or by when would you expect that the quantum computers available or quantum annealers available would actually give some practical advantage?
So at the moment, we are pretty certain that we can't outperform a classical approach, but so roughly, I say within the next 3 years, depending on how everything will evolve, we should be able to 2 or 3 years. We should be able to be faster than the classical algorithm.
Okay, thank you.
Yeah, Emily, you can go next.
Yeah, thanks. Thanks for the pitch. It was really clear, guys. Also, a question on that graph where you compare like the classical and the quantum problem solving. So you talk about how this is helpful for car manufacturers that have increasing complexity. Is there a way to quantify this complexity commercially? So what does it actually mean in terms of business, in terms of commercial side of things, that would push people to have to use this solution? Because it's one thing to kind of frame the problem size and frame the number of variables, but like what kind of customers would this apply to? And yeah, at what point is there a turning point for this motivation to become more prominent? If you understand that question.
Yes, I've understood it, and I would be glad to take this one. So that's a question of how not optimal is the current industry operating in terms of operating costs. Not only BMW, of course, but every big company that has a very big scaling supply chain. And your question is very valid for a pitch, and how would someone quantify the advantage being offered? But I'm afraid the answer is that first the quantum advantage has to be realized and it has to be solvable, and then compare maybe a year's revenue or a year's operating costs on that field, and then see the actual advantage that is generated by being sharply optimal on operating costs.
Okay, that makes sense. Maybe a note would be that investors are simple-minded and we look for like these big numbers. So it's good to put like how much it would cost them to not have the solution, even if it's an estimate, as long as you can kind of back up with like rough numbers what you're saying. But thank you, that makes sense.
Okay, that's great input. Thanks a lot.
Stefan.
Yeah, I was also interested in first the question that have already been asked by Frank about the D-Wave machines, but maybe a slightly different note. So how much do you rely on the availability of particularly these quantum annealers? Can you also switch to other, like if there is NISQ type architectures that will become more prominent and use other solvers? Or even if you find a better algorithm on a classical computer, would this still go within your business model, or do you completely rely on the availability of the D-Wave machine?
So for the supply chain optimization itself, we could switch machines, especially for the random forest gate-based machine would be maybe even better, but the D-Wave machine is also feasible. And overall, I think we could also change to gate-based machines. It would be no problem. But at the moment, the D-Wave machine is a straightforward solution for our problem.
Okay, thanks.
Next would be Christian.
Yeah, okay. I know this might lead a bit too far away, but I was just interested a bit in the more like math or technical details, right? Because I mean, of course, due to time constraints, you can't explain this in all glory, so to say. But anyway, just can you give a few hints or ideas how this mapping is actually working? I mean, so to say, how do you go from this random forest representation to something which runs as an optimization problem on a quantum annealer, right? I mean, this step was not really clear to me.
So we use a two-step approach. The random forest is solved for itself, and then with the results of the random forest forecast, we then optimize our supply chain at the moment with the well-known vehicle routing problem and all of its variants. And so we use those two different steps. And the vehicle routing problem is something that can be implemented, has a very well-known implementation on an annealer.
And if I may add something, so at the first part, we have the sales forecasting of models. Then this is translated to features. And these features, for example, black car models, and these features are then translated to parts. So parts are the actual entities that are optimized during the supply chain model. So based on setting the demand for specific parts at specific places, at specific points in time, deterministic as the output of the first part of the approach, then at the end, we have the optimal decision variables that tell us we need that many parts at this part of the echelon of this quantity. And the CO2 is optimized based on clustering these parts with a specific type of vehicles and also taking the mileage and the distance of the factories and the warehouses into account.
Okay, yeah, thank you.
Okay, cool. Last three questions, probably by Thomas, Elvira, and Worley.
Yeah, my question is quick. First of all, cool presentation. Interesting that you use random forest, which brings me to the question, why not knapsack? Did you look at the knapsack formulation? Because we're just working, and I just chatted with Elvira in parallel. BMW and in Kutak, we have kind of similar problems where people are looking at knapsack implementation. I'm just keen to if you could mention it in one sentence or so.
Yeah, so actually we also looked in Obsec and Random Forest, and we were looking at different machine learning algorithms that could be usable in this problem. And the reason that why we stayed with Random Forest, because for us it seems the most applicable to our problem. We do expect that it could be not the most optimal one, but because we are in the early stage of the development, we assume that it will solve our problem right now. But we are kind of open to, if we had more time to implement this actually as the model and simulate, as unfortunately was kind of a problem to us because we had to stick with one idea and just try to focus on that. I think we wish we could try more approaches. We stayed with the Random Forest as it's looked to us the scalable part of the Random Forest algorithm. When you scale it to the quantum, it looks to us very promising.
That's cool. It's really good finding, because then we just take it over because we're not sure what to do anyhow, which approach. That's really helpful. Thanks for the comment.
Well, Elvira, here we go.
Yeah, very quick question. Well, first of all, congratulations. The presentation is great, and it was great pleasure as well to work with you guys. The quick question regarding the landscape of competitors, there obviously probably exist already companies or startups who does the same work, but maybe on the classical way. Have you maybe had time to check what we do and what are exactly the metrics that could help you to be competing with them? And is there actually the sense to let's say to compete or to improve, and what exactly to improve?
So I can take this one. We have actually done a market research, and we have done also a competitor analysis. We have the names of the companies like Cambridge Quantum or D-Wave. So we know that these companies tackle manufacturing and supply chain optimization problems, but to what extent and how exactly do their approaches look like is not familiar to us right now.
Cool. Burley, then last one for you.
So I'm wondering if you guys have thought any about the unit economics and your go-to-market strategy. So the presentation was fantastic, and from a technical perspective, it was great. It sounds like maybe there's a little bit more work to do on the go-to-market and competitive. How would you actually take this in the market, and what do you think those unit economics would look like?
Okay, so the first step, how should we take it to the market? First of all, we would need to, I think that's a general question for every quantum idea and every quantum application. We would have to keep believing in that we can achieve what we presented to you, that we are able to go to a company and extracting from their ERP database some data, we can actually come up with a solution which is more optimal than the way that they are currently operating. And once we approach the first customer, which in our case is our partner BMW, and build a success story based on this, then maybe the idea is to found our startup and reach out to more customers if we operate on our own without being bought or being absorbed by BMW. So that would be the business plan.
And just to add to your answer, Andreas, our pricing strategy allows us to work with customers with proof of concepts. So we can prospect customers and elaborate tailor-made solutions with them, and then they can choose us to work and choose our product.
To add on to that, one final note, I think it's also a concept that could gain momentum very quickly once we've broken into the market and we've worked with a few different companies. I think we can gather a lot of anonymous data that would really help make our point, concrete numbers, like were mentioned before, that show that our product really does give companies a competitive advantage.
I guess Thomas already gave you idea to go directly to Kotak, the consortium where a company is actually trying to solve exactly the same problem.
There you go, guys. Go-to-market strategy is solved. And with that, once again, huge thank you and congrats to the presentation and answering all the questions. And we jump to our next team because it's also time. And next up would be Rescue.
Yes, all right, let me share the screen. Are you guys able to see everything?
Yep.
Yes, we can see it. Perfect. Thank you, Yannick. So I will just go ahead right away. So hello, everyone, again. We are Team Rescue, and we use the power of quantum to make the electric grid more resilient. First, let me introduce you to Sabrina. She and her family live in a house in Munich, and now imagine her situation if there was an outage. No fridge, no charging her phone, no light, nothing. It's a situation probably none of us would want to be in. So who are the ones making sure that doesn't happen? Who are the ones who can help Sabrina? It's the DSOs, the distribution system operators. They're the ones who take care of the grid management and the ones who deal with those kind of outages. After the electricity is generated and transmitted, the DSO distributes the electricity directly to the end customers, like Sabrina. At the moment, the DSOs have no reliable predictions about outages and therefore cannot take any measure to prevent them. They cannot use their resources efficiently for the grid management, and the outages also lead to a loss of revenue. But what if there is a way to predict outages, just like the one Sabrina experienced? Well, I have good news for you. To tackle exactly this problem, we created Rescue. With Rescue, making the electric grid more resilient was never this easy. By providing the location and the reason for grid outages, we can help the DSOs to react earlier, to reduce their power losses, and to save costs. So, how does this look like, Yannick?
Hey, welcome. So welcome to our software solution. Let me jump over to the demo. This is what the user working at a DSO sees at the status overview as a dashboard. He has a direct overview of the number of alerts, of the current status of the resiliency of the grid, of the amount of renewables intake, and of the amount of blackouts that happened in the past and now. Below that, you can see a nice map of Germany, where every county and its resiliency is presented. To the right, you have a historic view of real-time resiliency scores and a share of the current good, warning, or severe state counties with the top 5 worst counties at the moment. If you want to look specifically at a county, you can go to this all county list and search for the county you are searching for, or just sort after resiliency. As well, our software solution provides the possibility of alerts. An alert can happen whenever a status change to a given threshold, in this case severe, is taking part, and you can directly hook it into your current company's communication, be it a Slack webhook, a Teams webhook, or just the basic usual notification email. But what is this alert all about, and what can you do about it? So let's look at the counties again. We can pick at this one, Reutlingen, which currently is surely in a severe state. The resilience of this part of the grid is just at 0.95%, so really bad. But you can look here at the past resiliency scores, and as well to the score of all the subnets of these counties. The subnets are the parts that actually connect the high voltage grid to the house of Sabrina. And now the cool thing, you can directly send the report to the technician or the surveillance mission, where these buttons or these actions can be incorporated in the company's incident management protocol and can be adapted to each customer individually. So how do we generate all this current real-time actionable data? And how can we, with that, prevent Sabrina from having outages again, and save some money to the pockets of the DSO.
We have implemented our solution in 3 different ways, using a machine learning algorithm and grid data provided by E.ON. We have run our algorithm with a classical machine learning algorithm, which provides the basis of our initial solution for DSOs. We have also used a quantum machine learning algorithm and run this with the quantum simulator KISS-Kit. And we have run our quantum algorithm on a real IBM 27-qubit quantum computer. Our solution works by taking in data about subregions of the grid and then classifying these regions as resilient or not resilient. And we use the probability of being classified as resilient as our resiliency metric. Currently, our metric accounts for past outages, but in the future, we'd like to include more information in the resiliency metric, such as the connectivity of subgrids. Our grid data involves different properties of the subregions of the grid, such as renewable in-feed and gas in-feed. Now I'll explain how our classification works. We use the machine learning algorithm called the support vector machine, or SVM. We begin by feeding in past data about the grid, which initially can't be directly separated into the 2 groups. So we need to map this data to a higher dimensional space where it can be separated into the 2 groups. Then we can use this data to train our SVM, and we can use our SVM to predict whether the data for subregions will be resilient or not resilient.
So we have seen that the key step for the classifier is this technique of mapping the data into a higher dimension. This process can be proven to be significantly faster with quantum algorithms than with classical, thus enabling us to characterize the grid in real time, which is exactly what anyone working in grid management wants. In general, there is no rule of thumb for choosing a mapping technique. Therefore, we can think of quantum as giving us more choices. We choose a quantum feature map that is not easy to simulate classically, allowing us the possibility of achieving a quantum advantage both in resources and in accuracy. In the future, as quantum hardware progresses, we expect the availability of more qubits to allow us to take into account more data points without reducing them down as is currently necessary. We also plan to train and implement our solution using quantum computing, which allows us to give predictions in real time to the DSOs. With this, we can expect an exponential speed up over classical for our solution with respect to the number of data instances. This is particularly important with the advancement of smart grids and an increase of renewable energy in-feed. There'll be huge amounts of real-time data, making this quantum speed up vital. Finally, the quantum algorithm is expected to be more robust to noise and outliers, meaning we will also provide better accuracy and avoid more blackouts.
So why is our solution better for managing the grid than the existing ones? For the quantum competitors, you can see that there are only 2 research projects right now, and none of them focuses on the grid resiliency or the DSO. So they're not very customer-centric. Both projects are also very early in the development phase. So once we launch our product to the market, we plan on becoming the market leader. There are some startups working on classical solutions to improve grid resiliency. However, with our unique and most importantly, real-time grid resiliency score, the DSOs have way better insight into the status of the grid. Besides that, our solution is more actionable. What does that mean? If there is a problem or an outage in the grid, the DSO can directly act on it. With the push of a button, they can notify a technician who can then have a look into the problem.
So, what does our business model look like? Our software as a service model will have a monthly license fee of 5,000 euros and additional one-time payment implementation costs of 10,000 euros. Rescue also provides additional long-term customer services such as data consulting, customized features, and a variation in the number of software users. Let's have a look at the grid software market. It is a growing market with a global total available of 23 billion worldwide. The European grid software market is estimated to be 120 million in size.
We, as Rescue, have the realistic goal to tackle 5% of the European market by 2028. What are our next steps? So now we are in the proof of concept phase, doing a pilot project with E.ON and feature refinements of our software. Next year, we want to launch our product and have a viable MVP. Additionally, we are implementing security features to ensure protected data and enhance real-time data through our algorithms. Further, we are going to scale our product with recommendations, meaning to automatically consult companies to make their grid more resilient. Also, we want to go international within the European Union, as well as focus on data integrations to then be a market leader in 2028 by having a quantum advantage, aiming to offer 0 blackouts via renewable energies through our software. This is our interdisciplinary and motivated team, consisting of 2 quantum specialists, Emily and Maria, a software engineer, Yannick, and 2 business experts, Dani and me. We are ready for a new era of grid management. Are you? Feel free to try out our prototype by scanning the QR code on the right. And thanks for listening, and we are open to any questions.
Thank you, guys. Great presentation. And thanks for preventing us from blackouts. And with that, I would open it for questions by our jury. Stefan, you first.
So thanks for that very nice presentation. So I was wondering, because it didn't get clear to me, so how many qubits would you need? How large is the input data actually when you get to this advantage? And also, did you consider then how do you input this data, this classical data, into your quantum support vector machine?
So essentially all of that is coming with the advancement of quantum hardware. So we don't really know the exact timescale on that. But basically, as the smart grid advances, we will have more data sets that we will be able to take into account. So it just becomes more accurate with that. That makes sense.
Maybe one addition from my side. So as well, we are using at the moment a PCA beforehand to reduce the dimensions. And so we can already use our classical solution, or in time then replace the complete classical solution with using the quantum one, to then with the qubits be in time able to scale the amount of dimension intake from 10 to 15 to 20. So we scale as the quantum hardware scales. And until the quantum hardware is ready, we can use our classical solution, which already provides the benefit.
Okay, thanks a lot.
Perfect, Emily.
Yeah, thanks for the really nice pitch, guys. Again, well done. Can definitely see the value of what you're doing, especially because all this becomes much more complicated as you integrate renewable energy sources and you have bidirectional grid management. Kind of same as before, like how do you quantify, I guess, as a rough image, because I know it's difficult to put exact numbers, like the value that you're bringing to DSOs? And then a second question would be, like, DSOs are kind of notoriously difficult to work with. It's kind of like long sales cycles and difficult for startups to come in and disrupt things. Like, how do you guys think about managing that, and how are you going to be successful doing that?
So maybe I can start, Valentina, if you want to add something, feel free to do so. So basically the pricing that you saw on the slides previously is based on the value that we would bring to the DSOs. So we really based the monthly license fee that we had. Like we calculated the costs that would arise from having those outages by the interruption fee that the DSOs would need to pay, and came up with like the yearly cost that a DSO would have. And we roughly wanted to charge like 1% of those costs, and broke that down to the 5K monthly fee that we would charge the DSOs. So even though like, so I think this can kind of quantify like one aspect where we bring value. Of course, we would also generate value by allowing the DSO to use their resources more efficiently, that we right now did not, or we're not able to quantify. I think we can do that once we actually are in the pilot project. Mm-hmm. But yes, and for the second part of the question, you mentioned the long sales cycle. So first of all, I think it's very crucial for us that we have that pilot project with with E.ON, and that we can really prove that this brings the advantage that we are promising. And I think what is also important to mention, with already I think we would need 10 customers per year and to actually get the market share that we presented earlier. So we still have those 5 years to get up to achieve those 10 customers, which I think is realistic to do. So I think we first need to prove that we are really good at what we do. And then I think we can also manage to achieve those goals we presented.
Perfect, thank you. I'm sure you will be able to prove that you're good at what you're doing.
Thomas.
Yeah, really nice presentation. I loved it. Again, I have this stupid question on algorithms. You mentioned that you had to do a PCA, so principal component reduction. That's maybe just due to the fact that there are no other feature reduction machines. Because the challenge, we just actually, repeating myself in Kutak, we're just learning that it's super complicated due to the lack going direction Stefan had mentioned. The lack of hardware, you cannot train your machines with a lot of features, and parameter space maybe is better with 2 parameters than with 15. I just wonder how you are preparing your software in a flexible way that you could as well live in the NISC area, but also prepare for 2028. Is there any guidance or roadmap that we can learn from for other problems? It might be helpful.
Maybe let me take this as well as with the PCA. I guess for us it's most important that we first focus on the customer. And for example, E.ON at the moment has no real-time overview of the current state of resiliency. And so for this, it already is important to have it with 2, 3, or 5 or 10 features. But obviously the scaling, and that's our hypothesis, that with the scaling we can get more and more accurate. Mm-hmm. But how this actually goes is something that we cannot guess on.
Yeah, sure. I mean, it's a trick. It's a tough question, so don't worry. Thanks.
All right, Verly, we're up next.
First of all, I love this idea because, as you may or may not know, last year the entire Texas electric grid crashed for over a week and nobody had power, and it was a horrible disaster. So having lived through that, I applaud you for approaching this problem. My question is, a lot of these electric grids in various parts of the world, Asia, the US, or whatever, which I've been studying to try to help the state improve our grid, they're often managed by very politically driven relationships. So for example, ERCOT in Texas is a board that has nothing to do with anything, but they approve the software purchases and the things like that. How much have you guys checked into things like regulatory compliance or the regulatory environments of some of the target customers, those 10 you said that you need to kind of get to where you want to be?
So maybe I can answer this question. Right now, we have to say that we first really focus more on the software part and getting it to work than on fulfilling all the regulatory requirements you would have. I think one thing that is important to mention is that it's definitely on our roadmap to make sure that we stick to all those requirements, especially the security is one big thing we want to focus on, having the data security, especially with that super grid, sensitive data of the grid. But the specific things the specific steps we would need to take, we still would need to figure that out in the future. Yeah.
Cool. Then last 3 questions by Frank, Christian, and Elvira.
Okay, maybe so since the kind of the mix of energy, or there will be more renewable energy sources coming up, and probably there are more fluctuations than in this grid. Is it realistic that you will still be able to make good predictions, or is it getting harder as there are more renewable energy resources? Or does it not have any effect on it? I have hardly any idea.
That's exactly one of the issues that we're trying to solve here, that with the increase of renewable energy, it's making the grid less predictable. But one way to counteract this is the smart grid. So we'll be able to measure. And so every time anything like a solar panel gets implemented or introduced to the grid, it is coupled with a smart meter. And so being able to take the data from that and to be able to use it in this classification is what we're offering here as sort of our advantage. Does that answer your question?
Okay, thanks.
Christian.
Yeah, my question would be, did you also consider a physical model of actually like what happens in an electric grid, like some kind of, I mean, what I'm thinking about is, for example, one could maybe track how much a certain electronic, let's say, transformator or like something which does some work in the grid is used, right? And use that as a, if it's kind of overburdened with work, as an indicator that it might fail or something. I mean, just generally, did you try to think of more like really a physics-based approach of this issue of failing components or resiliency?
So we've been focusing on the type of information that's already collected about different parts of the grid to try out our solution with the data that we could get from E.ON. But I think our solution provides a flexibility in being able to add more information to that we're collecting about the grid. So that's something we could look into adding information about whether things are likely to fail into our algorithm to improve the classifier, or even more different features in the future. We could add to that as well.
And it might, I mean, just as a comment, right? I mean, usually one also wants to know what failed, right? Or why something failed, not just that something went wrong. And especially when you, I mean, even if you can predict a failure, right? It doesn't mean you actually avoided it, right? I mean, that's a second step here. But I mean, of course, I guess it's really hard in practice, but.
Yeah, I mean, this is, if you like, in the roadmap, there was this recommendations. So at the moment, we are already a first mover in actually providing those insights and predictions. So at the moment, it's mostly, okay, there's a failure that happened, and then we start searching for an error. And knowing when to start for an error already 2, 3, 4 hours earlier can save already a lot of money. But obviously, once we solve that, then we can continue in providing these recommendations, which are exactly then heading into this direction, that we have a list of, hey, to actually, before something happens, fix the problem, you should look at specifically this subnet, or at some point even some part of the subnet. But this is then step 2.
Okay, yeah, thank you.
Perfect. Seems like we don't have any further questions. We're also at time. Then thanks again, Team Rescue. Great stuff you have put together. And next up would be Team Locus.
Very nice. So, okay, let me share my screen. Okay, can you see it?
Yes.
Super. Okay, well, hello, ladies and gents. We are Locus, and we will help you to find the right place for your business facility with satisfying results. So I will show you what happens very, very frequently. So this is a business owner, and he asks himself, where should I place my business facility to increase customer satisfaction and maximize my profit? So how it's done actually is that he either go for a self-made solution, or he asks for a consulting, but the method that is done is the same. Desk research on Google, surveys and questionnaires, classical technology, and the problem is that all these methods output wrong locations, because the locations are not optimal, they cost in terms of time and money, the facilities have low revenues, and the customers are unsatisfied. So we just thought, what if we leverage the power of quantum computing to optimize the business facility locations? So we are here, we are Locus. We are a software for facility management that helps business owners and facility managers who want to optimize the location of their facility by reducing facility costs, increasing revenues of existing facilities, minimizing customer travel time, using real customer data. But why Quantum? Walid will answer the question.
Right. So to solve such an NP-hard problem, a variety of classical approximate techniques have been developed for the facility location problem in the literature. For scale problems, let's say a whole country, a number of these approximate methods fail to provide a good solution or take a tremendous time to execute. And this is why quantum computing solution that improve current classical approximate solution within a reasonable time. This is why we incorporate quantum technology in our software to leverage their power for big system sizes. Now let's see at which point we will see a quantum advantage using our model. Numerical simulation with our model have estimated that an experimental advantage would require hundreds of noisy qubits for quantum speedup, and with a gate fidelity approaching 99.9% for gate-based quantum computers. Our products allow us to choose the best solution with a combination of both quantum and classical approaches. There are a lot of use cases for our products, and now we will show you an example from the banking sector. Our banker, Jane, is wondering where to put ATMs all around Nuremberg city to increase customer satisfaction and maximize profit. But this time, she used Locus, the only software that optimizes facility location management using both classical and quantum approaches. Now, Michal will show you how it works.
Okay, so let's see how the prototype works. Let's just log in. Now I can select my industry, my facility type, my country, and my city, and I click forward. I can upload my current facility and customer data. I click forward again, and after some loading time, I see how is the current situations with a couple of statistics. I can click on Analyze. And now I see that the 3 current locations are inefficient. I also see the average walking distance to the ATM as well as the total profit. What I can now do, I choose the optimization method. I choose the desired number of ATMs. I choose my metric, and I choose the grid density. And when I run it, I have an optimized solution, which I can export. Okay, so that's how it looks like, but how does it actually perform? We performed a small study on 1,000 customers in the city of Nuremberg, which we distributed randomly, as well as with random profit. The total profit amounted to €1 million. And we assume that the further they are from the nearest ATM, the more likely they are to leave the bank. So we first tested our model on the current market leader for optimization, classical market leader, and the results weren't really good. So we switched to Annealing, and we tested 2 versions, one with random points on the grid, one in the map, one with a grid. And the grid performed a little bit better. And here's also worth to mention that simulating annealing outperformed a little bit the actual quantum annealer, but we are gonna offer both because it might change from problem to problem. Now, the final advantage that we had was almost 1 kilometer of average distance to the nearest ATM, as well as 8.8% profit increase. And Pablo will now explain how we arrived at these numbers.
So we formulated the problem as a quadratic binary optimization model. So we can set the variables to be 1 or 0 so that they will say if an ATM is activated or not. Using this model, we will have the cost function, that is the Hamiltonian of our system, which gives us the energy, that will be minimized in the quantum annealer or in a universal quantum computer using QAOA. This Hamiltonian can be modeled in a matrix containing the coefficients of each variable and pair of variables. In this case, the constraints will be divided in two terms. On the first place, we will take into account the distance of each ATM to the customers. To do so, we will consider a circle of radius r around each ATM and compute the distance to each of the customers that fall inside the circle. We will also classify each customer based on the transactions he made in the past. This way, we are assigning higher weights to the ATMs that are closer to better customers. If we choose the radius of the circle to be higher, this would mean considering more clients on the weights of each ATM, and therefore assuming a higher mobility of them. This will be chosen based on data about the mobility of the clients. On the second place, we will consider a maximum distance so that for all pairs of ATMs, if their distance is closer than this quantity, then we will add a coupling term between them so that a penalization in the cost function will be introduced if both of them are activated at the same time. This means that we will not let those two ATMs to be open in the final solution. By changing the maximum distance, we will be able to let more or less ATMs to be open based on the necessities of our client. And now Francesco is going to talk us about the customer profiling.
Thank you, Pablo. So our customer profile, our customer is basically a business owner, a facility manager, or a facility consultant that needs to cut facility costs, that needs to take location decision, that works for a corporate with multiple facilities, that monitor the facility performance, needs to know the customer location, and needs to optimize the customer travel time. Our target facilities are as following. As of now, we are targeting the ATMs and we are building the model around the ATMs. But then we will also start to target our removable facilities, for example, antennas or vending machines or charging the station for electrical cars that can be easily moved around. But our long-term vision is also to apply this model to shops and maybe also factories that are more static. We are in the supply chain management software as a service market, and the market size is around 15 billion worldwide, and for the EU is 2.9 billion euros. And we estimated that in a few years we will reach about 3 million euros in revenue, and that's our sum. The market is expected to grow at a rate of 11% per year, more or less, and it's going to be in 10 years more than double than the current amount. Locus is efficient and data-driven. That's the real difference between its competitors. On the other hand, you have mostly the consultants, can be more or less specific, focused on the location, or you can also have, for example, other softwares. But what we do basically is to really find a real solution that works and optimizes the current facilities. So what we offer is basically counting a basic plan for 420 euros per month that includes one user and one city. For each additional city, the price increases of 220 euros per month, and to add another user, you also had to pay 40 euros per month. But what we offer is basically facility monitoring, then the possibility of running a quantum optimization, and then to update the customer data to go again and monitor the performance of the facilities. Our roadmap is as following. As of now, we are still in the proof of concept, and then we will have an optimization refinement. After that, we will go through an advanced business plan for precise financial forecasting. Then we start the resource acquisition phase, and we're talking to investor and partners. Then we will start the software development phase, and we will add the facility location monitoring and the possibility of tracking the customer location. And then finally, we go to the market entry. on more or less in 1 year from now. And hopefully in 2024, we will implement a QA implementation, reaching a gate-based quantum advantage. With that, this is the team, and it's me and Pablo, Michal, Walid, and we are 1 business expert and 3 quantum developers and quantum experts. So with that in mind, thank you for your time and looking forward to your questions.
Thank you, guys. Great presentation. And also for you, huge round of virtual applause for what you've done over the last couple of weeks. Really impressive. With that, again, to the Q&A part. Burley, you still have your hand up, or do you want to go with the first question? You're muted.
Apologies. I'm very interested in what research have you done on the return on investment for your customer. The reason I ask this is you're using ATM and cell towers. I happen to have a lot of knowledge in this particular area. And although you're optimizing where they should be placed for convenience, what are you doing about the actual implementation? So for example, a ATM on Fifth Avenue would obviously potentially cost more to have, like some of the retail contracts. So for example, for my building, I can't put an ATM there without the landlord permission, etc. How much are you looking at the other factors that aren't just the location for convenience based? So the cost of the location, things of that nature.
Okay, I think yeah, go ahead, Michael. Go ahead.
Thank you. I think that this is very easily to implement in our model, because the way you do that, you just have to put it in a number. So a cost will be very easily implemented. If this is some other, let's say, legal or time cost, you will have to somehow quantify it, but it will still output a good solution. So our model is quite adjustable this way.
All right, then next question, I guess, Elvira.
Yeah, I had pretty same question on how is flexible your model. Can you easily integrate, let's say, different criteria? So for example, if it's a, I don't know, city center, you have a lot of tourists, so you obviously need to keep more ATMs busy in this time, for example, in summer than in winter or whatever. But yes, so the second question is about the scalability of QoA, because there are many questions around that. For example, it's not only about quantum, but also about the classical optimizers who are not able to support a lot of parameters and somehow can provide you the right distribution in the end, or very picky distribution in the end, so you choose the right answer. Do you have plan B if QoA doesn't work?
Yeah, there it's true what you are saying, that the fact of optimizing the parameters in QoA is a problem, but also it's true that nowadays new techniques are emerging on QoA that aim to reduce the number of layers needed to reach a good solution. So that would consist on kind of a plan B to us. Just these new approaches that are emerging to reduce this number of layers, and besides that we also rely in quantum annealing, and that I don't know, you have seen that D-Wave is planning to release a new computer in the few years that we hope that could improve both the performance and the number of variables that can be handled a lot. And yeah, I don't know if that answers your question or not.
Just to add on Pablo's answer, that about the plan B, that we have been studying other models, one of which is a physics-inspired model that will require quantum simulation. And since quantum computers promise that one of their first application is quantum simulation in the near future, then we benefit our product from such an advantage.
Okay, and if I may, just one last So you compare it to classical, compared to quantum annealer, compared to gate-based approach, but there is now a group of suppliers who claim to provide already advantage for some of the industrial types of problems is the people who work with digital annealers. Do you think they might be competitors to you, or because we literally claim that we are able to solve the problems right now, so you don't need to wait the advantage? Or did you ever consider it actually, this cluster, as your potential competitors?
Yes, we did. Also, the thing about our model is that this formulation as a binary quadratic optimization model is very versatile in the sense that it's easily implemented on a digital annealer or also in the QA. It's just you have your Hamiltonian and then you just have to adjust it to implement in different technologies. So in that case, in the case that a big competitor could emerge, we could compete with it, just adjusting our problem a little bit.
Okay.
All right, then Thomas, next question from you.
Yeah, thanks. I like all these optimization problems. It's beautiful to see where everybody's going. And I have a bit of question, same direction like Worley and Elvira. Additional parameters, for example, if you say, I take also into consideration the value of my population. So it makes more sense to put it where many people live compared to where not so many people live, but those not so many people have much more money and go much more often to cash machines. So this additional parameters, I think you can easily optimize or include into your optimization equation. I would rather more interested than in following up. It's a kind of a self-fulfilling thing. So once you introduce a cash machine here and the competitor does too, maybe other markets get more interesting. So do you have an idea how to model these second order dependencies? So the outcome of your result on the proposed solution, is there any idea to predict this? Or maybe it's a bit of an academic question, but do you understand what I mean?
Yes, so you mean like what if some competitors place ATMs next to ours, and how will we handle it?
Yeah.
At the end, it will all be about the data we have. Like the idea behind the problem is very simple. You have some data and you can assign weights to your optimization problem, and it will be different outputs. So depending on the data we have, we could make very different approaches. Like now we have worked with dummy data. In the case you were talking to me, we could look at, for example, how often an ATM is used, how often this client is going to one or another place, and how it does correlate with a given ATM of another company placed in that position or not. So to do so, maybe like predictive models of machine learning could be used to assign weights to each ATM, so that, for example, if a competitor places an ATM next to yours, maybe this given place has a less weight, so it's not that prone to be activated at the end of the optimization problem.
Okay, thanks.
Cool. Last three questions by Frank, Stefan, and Corey.
Yeah, thanks. So you're considering this, as I understand, as a sort of a more static problem, and this also related to the question before. Could you also make it dynamic? So in the example of ATMs, for example, I assume that the number of ATMs needed is declining because people just more shift towards cashless payment. So is there a way to just make this dynamic so that you can just predict maybe the best solution for the next few years? Right? So there's dynamics in which time you set up new machines or replace others.
So I think our business model works this way that with time, you basically subscribe to it, and every time your clients change their behaviors significantly, you just optimize it in a new way.
But that, sorry to interrupt, but that would mean that you just do you redo a static simulation, but in principle, I assume you could also just use previous time-dependent data to predict what are the best steps to do in the next 5 years. Or is it too much to ask?
Like this, yes, I think we could integrate a time dependency. It would get like one step further in the complexity, something that we can easily do to try to predict where the customers will shift in the future.
Okay, thanks.
Yeah, Stefan, go ahead, please.
Yes, I always wondered actually whether ATMs is actually the best starting point for such a company, because the number is probably declining. And then the other question would have been how flexible you are, but that also has been asked. But then still, it's actually, I would be interested in how high do you actually think is the price for gathering all this data for a city to have all the different components that you need for your solution? Is this within your business plan, or do you have some assessment? How many people do you have to send to your customers to get actually what is the boundary conditions, and what is a best place for an ATM, and what is the cost for setting this up? That must be significant for getting all these for a city.
Well, actually, usually those data are already, like the customers, in our case, already have those data. So in the case of the ATM, it's easier because you just receive the data and we implement the model. So
that means you have to know your customer beforehand.
Exactly.
So it's not so flexible. Okay.
At the moment, for the ATM, we are working on data that are already available, but we are working in a way that in the future we can also somehow take the data. But at the moment, for this, in this moment of the time, we are working on data that already exists.
We identified a couple of use cases, which I think will work good with our business model. So that was, for example, where do you place your 5G antennas, based on where your users are, mobile users are. Where can you place your warehouse or a factory based on where your suppliers are? Or, for example, how do you place the electric stations based on where the cars move? And yes, for data, for example, from Google Maps. Yeah.
Okay, thanks.
Great. Last question, and Corey.
Yeah, hi guys. Thanks very much for the interesting presentation. I like the one picture and the fact you just commented on about the placing of the charging stations. I think that's an interesting application, at least from the E.ON side. I had a bit of internet outage at this point, so if my question was already answered, please excuse me. But did you guys implement it on a simulator? So you defined the QBO, right, for QAOA, and then how did you guys, how large did you define the problem, and did you run it in any kind of real way in preparation?
Yeah, okay, so we, to solve this concrete case we have shown in the presentation, we defined a grid of 14.14 points, so that we solve 196 variables on the D-Wave quantum annealer. Of course, nowadays that's not feasible with QAOA, so just we made proofs with 20 qubits, 18 qubits, and it's not like that, but yeah, it's more or less the number of variables, and like we have chosen this number of variables so that the couplings in the quantum annealer are somehow respected, so that like the annealer can solve the problem in one shot and does not need to divide it and make some further things so that the results are better.
Okay, so it was solved on the D-Wave and not a hybrid method. So it was really the solvers, which one shot, you give it everything, yeah?
Yeah, the thing there is that the higher the number of variables, so the more dense is the grid, the better the solution has the potential to be, because you are considering more points. But if you choose like a balance between high number of variables and a problem that is feasible to be solved just with quantum annealer, not with hybrid methods, maybe you can get better results. And that's what we did in here.
Okay, thank you.
You're welcome.
All right, thanks again, Team Locus. Great stuff. And next up will be Team Quest. Stage is yours, guys.
Okay, first off, can you hear me well?
Yes.
Mic check.
Okay, great. So,
can you see the screen?
Yes.
Yeah, okay.
Okay, so I'm having a bit of internet issues. I hope the connection holds. Unfortunately, there's nothing I can do about it. Maybe Rescue can offer a service for internet providers as well. But okay, so welcome to our pitch. We are Quest. Our mission is to lead the quest in enabling product label sustainability in the pharmaceutical industry. Looking at a pharmaceutical product or a drug formulation, it goes through 3 stages in its product lifecycle. There's 10 to 15 years of research and development in search for a new compound and running trials to find an effective medicine. Following approval for distribution, the drug is produced in high volume to make up for the cost of both successful and unsuccessful R&D. After the patent expires, the drug is produced as a generic. This is where Quest comes in to inform relevant stakeholders, such as process chemists, production engineers, and account managers to plan for the optimal way to ramp up production with both profitability and sustainability goals of the company in mind. Now, what are the difficulties in preventing the optimal solution from being used right now? We are convinced that the full potential of sustainability optimization lies at the product level. With this in mind, we solve the following problems. First, a lack of data dimension outside emissions for sustainability goals. Then, a lack of reporting throughout the value chain. A lack of transparency in the supply chain for prices and sustainability metrics. A long lead time for supplier onboarding and production planning. And the fact that it's difficult to determine optimal production quantity by weighing both profits and sustainability impact. Now, what does Quest do? Quest is a platform that consolidates and analyzes end-to-end production metrics in the pharmaceutical industry from suppliers and producers to drive sustainability, cost effectiveness, and transparency in the product value chain through optimization. Let's see it in action.
Okay, now to learn about what we do at Quest, let's look at a typical morning at work for Erika Mosterman, process chemist at Merck. Erika logs into her account where she has access to the 3 main tools that our platform offers. These are the supplier management, the data management, and the optimization tool. This last one is where the Quantum Quest takes place. Erika wants to optimize the path of production of one of her products in order to increase the sustainability of her portfolio, while staying within a given profit variance. In order to do this, she starts a new optimization. In this day, she will run the algorithm for 5,000 units of ibuprofen with an allowed profit variance of 4.5%. After inputting this parameter, Erika uses the filter section to tailor the process for her specific needs. Her selections will determine the options for each step in the production path to be included in the optimization. Finally, Erika chooses the sustainability goals she wants to optimize for her portfolio. After checking the summary of her order, she runs the algorithm and waits for the results. Once this process is over, what would the results look like? To see this, Erika heads to the details of the results section. Here, she finds all the information, including a set of optimal production paths and the percentage of the total volume of ibuprofen to be assigned to each of these paths. In addition, she finds the resulting profit variance and the sustainability score resulting from the algorithm. Now that her job is done, to learn more about the algorithm, Erika clicks on Learn More.
To implement this optimization, we formulate this problem as a knapsack optimization problem. In general form, the knapsack deals with the following question. Given a set of items, each with a value and a weight, pick a subset such that the value is maximized and the maximum weight the knapsack holds is not exceeded. Now, how do we apply the knapsack to our situation? Imagine this simplistic version of the production steps. At each step, a decision needs to be made. Which supplier do we choose? Which mode of transportation? And so on. In our case, each decision option resembles an item to put in our knapsack. Each option will perform differently in terms of how profitable and sustainable it is. To quantify this, we assign each supplier a sustainability and cost score. Our algorithm picks the optimal set of suppliers such that the sustainable score is maximal and we do not exceed the cost score. We then repeat the process for the other decision steps. This is just the base case for our optimization. As the hardware improves, we want to find the optimal set notch for each decision point one by one and then combine the result. Instead, we want to work our way towards doing so for the production process as a whole. This is where we need the power of quantum to handle this task. Quantum computing promises significant calculation speedup and massive additional computing power. How can we get a quantum advantage for our knapsack problem? We implemented an extension of QAOA, which is specifically designed to tackle the knapsack. Its modifications allow it to deal with the maximum weight constraint, which is inherent to the knapsack problem. To benchmark our algorithm, we compare it to two widely used classical algorithms, dynamic programming and greedy algorithms. In the thousands of test cases we ran on quantum simulating software with up to 24 qubits, it managed to perform very well compared to the two, even reliably outperforming the greedy solutions. Our algorithm scales linearly in n. If you compare the complexity of our solution to the classical algorithms, we can see that it scales more favorably. This is where quantum gives us an advantage in handling large and complex problems of our customers. Why do we think that Quest can solve these problems now? And it's crucial that we do it as soon as possible.
Against the backdrop of climate change, science and technology play a key role in the search for solutions for a more sustainable pharmaceutical industry. We benefit from several macro trends as follows. Digitalization, that's already up. It provides us with fresh data for optimization that simply wasn't there before, especially in an industry such as pharma. On top of existing red tapes in pharmaceutical companies, changing regulations impact sustainability reporting standards and increases costs on carbon tax. Next slide. Increases costs on carbon taxes and which in turn increase the value of our offering. A company focused on tackling problems in achieving sustainable product portfolio would help pharmaceutical producers find ways to make their operations greener. Here are 9 headlines that represent the dire situation of climate change, as well as the scale of the impact of the pharmaceutical industry. According to Erica's boss, Belen, sustainability is a vital element of our business and the responsibility we want to fulfill every day. Through our innovation power, we strive to create long-term value for society. This quote from our potential first customer perfectly illustrates the direction the industries are moving towards and the fit of our product, which we can see in the business model. We've offered analysis aided by quantum computing that provides unique insights for key decision makers in the supply chain. We enable transformation of the supply chain to be more visible and transparent for end customers. We're doing this with a variable cost model depending on the data collection process, detailed analysis needed, and customer demands in our effort to co-create value for our customers. $60 million is how much one drug costs to bring to the market, and making a 1% dent in that cost is more than $500,000. And putting those numbers into perspective with the entire market, that means the total available market of $1,200 billion in the pharmaceutical production segment alone. And I know what you're thinking is easy to throw big numbers around when talking about the big pharma, but we believe by saving costs in procurement and production setup and proposing sustainable production strategies, we can help the pharma sell better, cheaper, sustainable products, capture the serviceable, obtainable market in the short term of up to 100 million euros by focusing on dimensions such as excipients, packaging, and generics. This isn't even mentioning the environmental impact Quest could administer to the world in the long term. So how can we put a price on saving the world? For producers, we would like to follow a subscription model with individual pricing based on factors such as volume, complexity of their supply chain, detailed analysis needed, and the calculation speed depending on hardware limitations. For suppliers, we want to connect with them on the freemium model so we can onboard them to the platform as soon as possible in a hassle-free way and provide market analysis and demand prediction at a competitive price through their data. Looking ahead for a second, we have a lookalike prototype and a working functional prototype. We would like to combine the two in the foreseeable future and continue to pitch our idea to bring us closer to where we want to be, which is the go-to marketplace of raw materials in pharmaceutical and adjacent industries, and be the golden standard in production planning and optimization. And that's how it looks like in the timeline. We want to start a pilot project as soon as possible to continuously iterate our platform and our product offering and aim for a launch in 2025. We have a team full of passionate people with the right skill set in solving the problems we identified in front, Christian, Benjamin, and myself, Ian. Thank you for your time and attention, and we look forward to your questions and feedback.
Thank you, guys. Great job. And also a huge round of virtual applause for the work you've done. Questions? I see Corey already has his hand up, so you can make the start.
Yeah, thanks. So first off, fantastic presentation, and I really loved your user interface. That was, I think that was a lot of work, but very, very nice. And I also think it's quite impressive that your team had 3 quantum specialists and 1 non-quantum specialist, which I guess is the business guy. So yeah, in terms of coming up with everything that you guys did in terms of the business model, I think I just want to give you a small round of applause for that. So my question is about the size. I like that you mentioned that you really ran it on 24-qubit simulator, I'm guessing with Qiskit. And you mentioned that right now you're doing it per supply, there's different parts of the chain. So supplier, transport, plant, and etc. for the different versions of knapsack problem. Did you do any estimations on kind of qubit count or size you would need? Whether, if you combine them all as you're proposing based on your product rollout?
Yeah, so I can take this one. So really, so we are confident that we can get useful solutions for our customers for different kind of stages of complexity of the problem. So if we were to really look at it in terms of we optimize for every supplier and from every country and every production plant, this problem increases drastically. For example, Merck, they already have 60,000 suppliers, but we can do a lot of filtering. We can do a lot of shown in the demo, we can apply a lot of sensible filters. For example, we limit ourselves to a given country, or to just we just pick the top 10 suppliers to the most useful production plants, and so on and so forth. So we can really adjust the complexity of this problem to whatever the current hardware is capable of, and then scale up as the hardware improves.
Yeah, okay, thanks very much.
Christian, next question is yours.
Yeah, thank you. Yeah, thanks again for the great presentation and talk. My question would be, how did you in practice include constraints, so to say, into this optimization, right? Because yeah, there are you put some constraints on this problem, but they don't appear in the vanilla knapsack formulation, right? So how did you do this in practice?
Okay, so I will take that question. So they're basically, the way the algorithm we implement tackles this is like twofold. One point is that the algorithm, rather than using the general QAOA totally mixed state as input, the input is biased in a way. There's some classical pre-processing where the items of the knapsack are kind of rated like on their probability of being in the knapsack. So items with very good ratio of value to weight, they are already being biased. Like their qubit basically is being biased towards being more in the one state. And so this is one idea of already by using a biased input state. So the search space the algorithm uses or searches for is basically already trimmed down to more probable solutions. And then also just, the way then the weight is really put it to the algorithm in order to avoid solutions which are not feasible or which violate the maximum weight constraint. While we run the QA circuit, and after doing the measurements, the ones which actually violate the constraint are just put out and like not they are ignored. So the constraint is not formulated in the Hamiltonian or something, but rather by some classical pre and post processing, which allows us to not need additional qubits. While, for example, like alternative approaches such as QUBO, they use additional qubits to formulate the constraint, and we don't need those. That's why we chose this approach.
Yeah, sounds good. Yeah, thank you.
Okay, Thomas, you seem to have another question.
It's not a question. We clarified all questions beforehand. No, I really want to take the opportunity to thank the team for the tremendous effort they did and the solution that came out. I saw it Monday. I saw it today. It's fantastic. So it's the progress. And I just want to give you heads up. So one comment officially, because we are streaming on YouTube, so we do not produce ibuprofen, but else everything is okay.
Oops, sorry.
No worries.
Thanks for the kind words, Thomas.
Thank you.
And I just add a little bit onto that, because for this team specifically, it took actually quite a couple of weeks till we had them together, because unfortunately sometimes people drop, and this semester we really had people dropping from one team all the time, and they really missed a bit of time in the beginning, and I think they pulled it off tremendously over the last couple of days and weeks. So also huge congrats from my side. Corey, you have another question? Or is your hand still up? Then Emily, you can go.
Yeah, sure, I can jump in. So I'm not sure if this question has an answer really, but how much work needs to be done on the data before you can actually turn it into something useful? Because like you talk about the problem of transparency a lot, and the problem of transparency comes from initially getting those data sources in a good position and someone rating like a lot of these different variables in terms of, for example, like CO2 emissions or whatever other variables come into ESG. Like, how do you think about dealing with the assurance of the quality of your data before you can even start to play with the variables and constraints and then start to do the nice optimization that you're offering? It's a bit of a hand-wavy question. I'm not sure.
All good. I'll just take this one. You guys add on if I'm missing something. So first of all, great question. It's definitely something we've thought a lot about because of kind of the unique situations that is the B2B pharmaceutical supply chain. And like getting the data in the first place, I think that's one of the macro trends that we mentioned is the regulations coming in where it requires company to kind of collect this data and report it so that they don't get massive fines in producing things in the, so to say, like unsustainable way. So there's that data that we can rely on like emissions related and energy consumption related data already. Simply because, you know, if they don't do it, they'll get a massive fine. And then following that, it's, I think on the timeline is that not unlike our underlying technology Quantum, it takes time to set up this this kind of platform. It takes time to build trust and to kind of show them what value we can provide to both sides of the platform. So for producer, I think it's a little different. For suppliers, it's a little bit different. So I don't know if that answers the question in a superficial way, but
no, that was really helpful. Thanks.
And I would like to add, because that's actually the tough question we had. Can we have data, and where do we get data, and how do we define these matrices? And exactly the fact that we are posing this question puts now each and everybody in a position that we are saying, okay, now let's produce this data. So we have, for example, for our electronics business, we have also the question: how do we optimize our portfolio for environmental friendly production? And the production steps and the steps in between in production. And we sometimes just don't have the data, and we have never asked. And now we know that we need data in order to optimize. You need to know some sustainability parameters. And therefore, it's very important that we start this soon. We're better yesterday than earlier, and also share the fact that we need these kinds of data globally. I mean, everybody from our suppliers, we will ask our suppliers to produce this kind of data. because otherwise we just don't get it. And that's really very good question, Emily. And I think as an industry, we need to work on these kinds of things to make data transparent, that everybody could use them. Of course, not pricing, etc., but steps. Yeah. So how many CO2 do you produce by driving from A to B or whatever? These kinds of topics. That's really crucial.
Yeah.
Otherwise, we can't work on.
Thanks so much.
Don't steal in your show. Sorry.
Cool. If we don't have any further questions, then we're actually done with our last team. Thank you very much again. We can probably go back to the big group. Just probably a final part from my side. I mean, today these presentations always show me why I actually love this course so much. It's just great to see the work you've put in, all the ideas you come up with. So thanks a lot. Next thing we would have coming up is the breakout rooms here in the Zoom session. So Pablo, if you can switch